Cambridge Primary Science. Forces and motion. 4.1 Mass and weight. What is the difference between mass and weight? Is the boy in the picture correct? Mass is the amount of matter in an object. We measure mass in units such as grams and kilograms. The boy's mass, I weigh 35 kilograms, is 35 kilograms, but what is his weight? Mass and weight are not the same. To understand what weight is, you need to think about the force of gravity. What happens when you drop a book? All objects are attracted to the earth by gravity. The bigger the mass of the object, the bigger is the force of attraction towards the earth. Weight is the amount of attraction on an object caused by gravity. Objects with a bigger mass therefore have a bigger weight. We measure weight using a unit called the Newton. N. Newtons are named after Sir Isaac Newton, a scientist who lived in England about 400 years ago. He was the first person to explain what forces are. Measuring mass and weight. Mass and weight are different, so we measure them in different ways. Words to learn. Mass. Kilogram weight force. Gravity Newton. Which do you think has the larger mass, 10 grams of feathers or 10 grams of sand? We use scales like these to measure mass and Activity 4.1. Measuring mass and weight. Make a table to record your measurements using the scales to measure mass and the measurements using the force meter. On the table, write in the units used to measure the readings on the scales to measure mass and the readings on the force meter to measure weight. Place each of the objects, one at a time, on the scales. Record your measurements in the table. Then hang the force meter on a door handle or hold it in your hand. Put each of the objects, one at a time, in the plastic bag. Hang the bag on the force meter. Record your measurements in the table. Questions. 1. Compare the readings on the weighing scales with the readings on the force meter. What pattern do notice? What you have learnt. Mass is the amount of matter in an object. Weight is the amount of force that pulls objects towards the earth. We measure mass in kilograms and weight in newtons. 1 kilogram of mass has a force of 10 newtons on earth. You will need objects of different masses, plastic carrier bag, scale to measure mass, force meter. We use force meters to measure weight. Talk about it. Why do astronauts float in space? An astronaut on a spacewalk. 4.2 How forces act. When we drop a book, it. Words to learn. Exert force diagram. Falls to the ground. Gravity pulls all objects downwards. But can forces act in other directions? What forces can you identify in the picture? Activity 4.2. Investigating direction of forces. Put the book on the table. Does it move? What would happen to the book if the table wasn't there? Why? Hook one end of the elastic band around your forefinger. Pull on the other end of the elastic band. In which direction does the elastic band move? Why? Name the force acting on the elastic band. Hold the magnet above the nail. In which direction does the nail move? Why? Name the force acting on the nail. You will need a book, a table, an elastic band, a magnet, an iron nail. Forces can act in different directions. When you put the book on the table, the book will exert a downward force on the table. This force is caused by gravity pulling the book downwards. The force is the weight of the book. The reason the book doesn't fall is because the table exerts an upwards force on the book. Force diagrams. We can show the direction of forces on an object in a drawing called a force diagram. Each force is shown as a force arrow. When the forces are equal, the force arrows are the same length. Forces always act in pairs. In the picture, the book exerts a downward force on the table and the table exerts an upward force on the book. The two forces act in opposite directions. Questions. 1. Upwards force of table on book. Downwards force of book on table. A. Copy the drawing and add arrows to show the direction in which each of the forces act. B. Is one force bigger than the other? Say why or why not. 2. When you stand still, why don't you sink into the ground? Draw a force diagram to explain your answer. What you have learnt. Forces act in different directions. Forces act in pairs. Each force in a force pair acts in the opposite direction to the other. Force diagrams show the direction and size of forces. Talk about it. Why does a boat float on the water? A Vietnamese coracle. 4.3 Balanced and unbalanced forces. Words to learn. Balanced, unbalanced. Net. Activity 4.3. Which force is bigger? Stretch out your arm and hold up the book. Does the book move? What happens if you hold the book for 2 minutes? Questions. You will need a heavy book, a watch. 1. A. Upward force of the arm. 1b. Weight of the book. 1. What force is acting on the book? B. What force is acting on your arm? C. When you first hold up the book, is one force bigger than the other? Say why or why not. 1. C. Yes, force of the arm. 2. After holding the book for 2 minutes, is one force bigger than the other? Say why or why not. 2. Yes, the weight of the book. Remember that forces act in pairs. When you are holding a book, you use an upward force to hold up the book. The book exerts a downward force, caused by gravity pulling the book downwards. The forces are the same size but in opposite directions. When both forces are the same size, the object does not move. We say the forces are balanced. Weight of book. Upward force of arm. As your arm gets tired, you exert less upward force. The book exerts a bigger force than your arm, so your arm drops a bit. If one force is bigger than the other, an object moves in the direction of the force. The two forces are unbalanced. The arrows in the picture show the size of the forces. The longer the arrow, the bigger the force. When forces are unbalanced and one force is greater than the other, we say there is a net force. When forces are balanced, we say there is no net force. Weight of book. Upward force of arm. Neither side is winning. Are the forces balanced? What you have learned: when both forces on an object are the same size, the forces are balanced. When one force on an object is bigger than the opposite force, the forces are unbalanced. When two opposite forces are not balanced, there is a net force. Talk about it. Why can a flying golf ball break a window but a ping pong ball can't? 4.4 The effects of forces. We cannot see forces, but we can see or feel what they can do. Activity 4.4. Investigating what forces do. Put the ball on the table. Does the ball move? Blow on the ball through the straw. What happens to the ball? You will need a ping pong ball, black circle, a straw, a table, a book. Hold up a book across one end of the table. Roll the ball gently towards the book. Allow the ball to roll into the book. What happens to the ball? Flick the ball with your fingers towards someone in your group. Get that group member to flick the ball to someone else. What happens to the direction of the ball each time you flick it? Squeeze the ball gently. What happens to the shape of the ball? Are the forces in each case balanced or unbalanced? What can forces do? Forces can make things move. When you exert a force on a ball by blowing or rolling it, you make the ball move. Forces can also speed up moving objects. Forces can also slow down moving objects or make them stop. When the ball rolls into the book, it stops moving. The book exerts a force on the ball to stop it moving. Forces can change the direction in which an object moves. When you flick the ball from person to person, it changes direction each time. Each person exerts a force on the ball that changes the direction of the ball's movement. Forces can change the shape of an object. When you squeeze a ball, you exert a force on it. The force makes the ball change shape. Forces that change the movement or shape of an object are unbalanced forces. Questions. 1. We cannot see forces. Name 4 ways we know that forces exist. 2. How do forces act to break a glass when it falls on the ground? B. How do forces act to make a rubber ball bounce when you drop it? What you have learnt. Forces change the movement of an object by speeding it up or slowing it down. Forces change an object's direction of movement. Forces change the shape of an object. 2. Forces stop movement and change the shape of the object. 2b. Forces make objects move and change the direction of the object. Talk about it. Why does the front of a car crumple if it drives into a tree? Modern cars have crumple zones which protect passengers in an accident. 1. Forces can make an object move, make an object slow down, make an object stop, change the direction in which an object moves, motion, change the shape of an object. 65. 4.5 Forces and energy. A force is needed to make objects move or to stop them moving. When we exert a force on an object to make it move, we give the object energy. The amount of energy transferred to an object to make it move is called work. A force is needed to make the toy car move. Words to learn. Energy, work. A force is needed to stop the toy car moving. How much work is done? The amount of work done depends on how far the force makes the object move. The further the object moves, the more work is done as more energy is transferred. FRIEN. PROVID. The force from the boy's foot transfers energy to the ball. The ball moves and work is done. If no force is applied to a ball, it cannot move and no work is done. Questions. If there is a force on an object but the object doesn't move, no work is done. 1. Can an object move by itself? Explain your answer. 2. When you open a door, what force do you exert on it? B. Is any work done? Say why or why not. 3. How can you increase the amount of work done when you lift a book? Explain your answer. Challenge. Where does the energy come from to make this windmill turn? What you have learnt. A force is needed to make objects move or to stop them moving. Talk about it. Where do you get energy from to make objects move? Moving objects have energy. Work is the amount of energy transferred to an object to make it move. 4.6 Friction. Words to learn. Friction. Mitsui. Lubricate. Activity 4.6. What is friction? Rub your hands together for 30 seconds. How do your hands feel? Are they warmer? You will need a watch. Friction is a force which tries to stop things sliding past one another. Friction is caused when two surfaces rub together. Friction only acts on moving objects and it cannot make objects move. Friction slows down moving objects. Friction changes the energy of moving objects into heat energy as the objects slow down. How is friction useful? You could not walk without friction between your shoes and the ground. Friction holds your shoe to the ground, allowing you to walk. Think how difficult it is to walk on ice or a wet, slippery floor, where there is little friction. Which shoes are best for walking on a wet, slippery path? You could not hold a pencil in your hand without friction. It would slip out when tried to hold it to write. The pencil lead would not make a mark on the paper without friction. The brakes in cars, bicycles and other vehicles use friction to slow down and stop. When you pull the brake lever of a bicycle, the brake pads of the bicycle push on the rim of the wheel. This creates friction which makes the wheel turn more slowly. How is friction a problem? Friction makes things wear out. Because friction causes heat, moving parts in machines get hot when they rub together. Oil is needed to lubricate the machines and allow their parts to move easily. The oil forms a thin layer on the surface of the parts so they don't rub together as much. Questions. 1. How do we use friction to clean our clothes? 2. Think of 2 examples of friction making things we use every day wear out. 3. How is friction different from other forces? 4. How can we reduce friction? 1. We rub soap on our clothes to make them clean. 2. Examples. Pencil, clothes, shoes. What you have learnt. Friction is a force that stops things sliding past each other. Friction slows down moving objects. Brake pad, wheel, rim. Friction between a car's tires and the road make the tires wear out. Challenge. Is there any friction in space? Why or why not? Talk about it. How does a pencil? Friction can be useful as it helps objects to grip on surfaces. Eraser work? Hot. Friction can be a problem as it makes objects wear out and get 3. Friction cannot move objects, while other forces can. Use lubricants such as oil to stop moving parts from rubbing against each dices and motion. 69. Lubricate text here. Type text here. 4.7 Investigating friction. Some surfaces are more slippery than others. Why? Activity 4.7. How does a surface affect friction? Set up the plank so that it makes a slope. Type text here. A. Slippery when wet. Type text here. You will need a plank of wood, a pile of books, liquid soap, sand, black circle water, a matchbox filled with sand, a shoebox, a stopwatch. Put the matchbox at the top of the slope. Measure how fast in seconds the matchbox moves down the slope. Repeat the measurements another 3 times. Record your results in a table like this one. Time taken for matchbox wood to reach ground in seconds. Reading 1. Cover the plank with liquid soap. Put the matchbox at the top of the slope. Wood covered in soap. Measure how fast the matchbox moves down the slope. Repeat the measurements another 3 times. Pour sand from the matchbox into a shoebox. Predict whether the shoebox will move faster down the plank than the matchbox. Test your prediction on the dry wood and the soapy wood surfaces. Questions. 1. Compare the results for the 2 surfaces. On which surface did the matchbox move faster? 2. Which surface exerted the bigger frictional force? How do you know this? 3. How did the soap change the surface of the wood? 4. Why is it good to repeat measurements? 5. 6. Suggest a reason for your prediction. Think about which box has the bigger surface area. B. Why did you pour the sand from the matchbox into the shoebox? C. Suggest a reason for the results you obtained when you tested your prediction on the dry wood and soapy surfaces. Was your prediction correct? Name 2 factors that affect frictional forces between 2 surfaces. 1. The matchbox moved faster on the wood covered with soap. 2. The wood without soap. The matchbox took longer to slide down the plank when it was not covered in soap. 3. The soap, it made it smoother, more slippery. 4. To make sure you have not made any mistakes in your readings and to get relabel results. 5. A. The shoebox has a larger surface area to rub on the wood. This means there will be more friction than with the matchbox, which has a smaller surface to rub on the wood. Ball bearings. 5b. So that the force on the plank is the same in both cases. 5c. The shoebox should move slower on both surfaces than the matchbox. 62 factors. Surface area and the type of surface. What you have learnt. Frictional force is greater between rough surfaces than between smooth surfaces. Frictional force is bigger over large surfaces than small surfaces. Talk about it. How do ball bearings in machines reduce friction? 4.8 Air resistance and drag. Have you ever held hand out of a car window? What did you feel? Your air is a mixture of gases. The particles of gas push against things which are moving and create a force. This force is called air resistance. Another name for it is drag. Air resistance pushes against a moving object such as a car and slows it down. The larger the surface area of the moving object, the more air resistance there is. Air resistance also pushes against falling objects and slows them down. A parachute uses air resistance to work. It is very light in weight and has a very big surface area. It catches lots of air in it as it falls down, so it creates a lot of air resistance or drag. Words to learn: air resistance, drag, surface area. Which has the greater air resistance, the pickup or the lorry? Activity 4.8. Making a parachute. Cut out a square from the plastic bag. Trim the edges so it looks like an octagon. An 8-sided shape. Dot. Cut a small hole near the edge of each side. Thread a piece of string through each of the holes. The strings should be of the same length. Glue. You will need string, black circle plastic bag, sticky tape, weights, scissors, watch. With sticky tape, join the strings to the object you are using as a weight. Stand on a chair to drop your parachute. Remember that you want it to drop as slowly as possible. Record the time for the parachute to reach the ground. Check your results by dropping the parachute another 3 times. Record these results in a table. Questions 1, 2. Name 2 forces that acted on your parachute. B. Draw a force diagram to show the forces acting on the parachute. Calculate the average time it took your parachute to fall. B. Suggest a way you could change your parachute to make it fall more slowly. 3. Would your parachute fall faster or slower if you tested it outside on a windy day? Give a reason for your answer. 1. The weight of the person and the air resistance. What you have learnt. Air resistance is a force caused by air pushing against moving objects. Air resistance is bigger over large surfaces. The space shuttle lands with a parachute attached. Talk about it. Why does the space shuttle have a parachute attached to it when it lands? 4. Check your progression. 1. Name the type of force acting in each of these pictures. Magnetic force, gravity, friction, elastic force. 2. 3. When an astronaut stands on a weighing scales on Earth, they read 60 kilograms. The astronaut travels to planet X, which has half the gravitational force of the Earth. What is the astronaut's mass on Earth? 60 kilograms. B. What is her weight on Earth? 600 N. S. What is her mass on planet X? D. What is her weight on planet X? 60 kilograms. 300 N. Describe 4 ways in which the picture shows the effects of forces on objects. 1. Force changed the shape of vehicle. Force changed the direction of vehicle. Force changed the position of vehicle. Force changed the movement of vehicle. Lubricate. To lubricate. 4. Draw a force diagram to show the forces acting in this picture. 5. B. The 2 forces are balanced. He is not moving. 5A. To reduce friction with the road, so they can go faster. 5B. To make sure they have friction to grip the road surface well and do not slide off the road. B. Are the forces balanced or unbalanced? Say why. 5C. To give them a smaller. Explain the reason for each the following. Surface area. Racing cars have smooth tires, which reduces air resistance, so they can faster. B. The tires of trucks have lots of grooves. C. Racing cars are low, flat cars. For each picture say if work is being done or not, and why. No work is being done. The book and the table are not moving. Work is being done. The wheelbarrow has force exerted on it to make it move. Work is being done. The parachute is moving downwards, pulled by the force of gravity.